Welcome back. This is Mr. Wakefield, and today we're talking about factoring polynomials. Basically, what factoring is all about is taking a polynomial, as you can see down here, there's a number of them, and breaking it down to where you have two or sometimes three things usually being multiplied together. Those things that are being multiplied together, sometimes there could be a term in there being multiplied by some brackets. Sometimes it could be just brackets only. We'll see how that all looks here as we go through each problem. But the key thing you always got to remember whenever you're asked to factor a polynomial is to always look for the GCF first, okay? Most problems have a GCF of 1, which usually means that you don't have to factor it out. And so it's really easy to forget to look for the GCF sometimes if so many problems are such that you don't have to factor it out because the GCF is 1. So you really have to discipline yourself to keep looking, okay? In fact, in these problems down here, there's going to be just 2 problems out of the 9 that you have on this worksheet plus 2 additional problems on the next sheet that we'll see here in a little bit. Those 2 problems are problem B and problem G. So let's go ahead and start with those. I'm not going to do the whole problem yet, but I just want to start those problems since we do need to find the GCF first. Let's see how it looks to start off the problem. Okay, so like for example, in this problem, the GCF is 1. I'll get into why that's true here coming up. So we're going to skip that step, okay, because if you factor 1 out of something, it doesn't change it at all, okay? Because it's like saying 1 times something is equal to this. Well, 1 times the same thing would be equal to it. It's kind of like if I said, hey, the number 8, what happens if you factor 1 out of that? That means you have 1 times something equal to 8. Well, 1 times 8 is equal to 8. You see what happened there? Nothing changed. The 8 is still 8. The goal here in these problems is to break it down into smaller parts. Like, for example, 2 times 4 would be an example of something where you factored 8. Not that we're ever going to be factoring a small single term like this, but that's just an example. You want to break it down to smaller parts. Okay, 1 times 8 is not doing that. Okay, 8 is still the same size. So here, what is the GCF if it's not equal to 1? It is equal to, let's find out. What you do, just to review with you here, how do we find GCF? The first thing we do is we look at the coefficients. And just for the sake of the GCF, not the whole problem, but just for the sake of the GCF, you don't need to pay any attention to the minus signs. Okay, just look at the 2 and the 72, even though this is actually negative 72. Okay, what you do is you look at the smallest number and you look at the factors of that number. The factors of 2 are 1 and 2. Okay, because those are the only 2 numbers that divide evenly into 2. Factors are numbers that divide evenly into the number that you're talking about. Okay, so just a little review right there. Okay, so for example, 25, what's the factors of 25? 1 in itself are always on there, but also 5, okay, is also a factor of 25. Those 3 factors, those are the only factors of 25. Okay, so just a little review with you there. So what you do is you take the smallest number out of the 2, or 2 and 72, and what you do is you start out with the biggest number. Okay, does 2 divide into 2 and 72? Yes, it does, and so that must be it. You got to start out with the biggest number. And now, if that had not worked, if 2 had not worked, then you'd try the 1. Okay, and you keep on going down if there's any more numbers after that. Start out with the smallest number, list out its factors, and then you start out with the biggest one. You work your way down to smaller numbers until you find one that works. We'll try that again here on problem G, but let's go and finish up this, at least the first step of this problem. So what you do is you put a 2 right here. Then the variable part, that's also a part of the GCF potentially as well. What you do with the GCF as far as the variables are concerned is that it has to have the same letter. This does, x and x. But it also has to have, well, no, that's actually the only requirement is it has to have the same letter. What I meant to say, though, was once you discover it has the same letter, then you choose the smallest exponent. That's how it works with the greatest common factor. Smallest exponent. And so x3 and x to the first is the smallest one. And so that's your GCF right there, 2x. Okay, so you do the coefficients, figure out the 2 from that, and then smallest exponent gives you x to the first. Make sure that these are being multiplied together 2 times x, not 2 plus x, okay? Then what you do, once you find the GCF, you then have to go like this. You put a bracket next to it, make the bracket big enough to fit the same number of terms that are up here. Excuse me, since there's 2 terms up here, because of the minus sign, that means there's going to be 2 terms in here. So what you do then is you say, okay, 2x times what is equal to 2x to the third? Okay. Now remember, when you multiply terms, you are doing what? You're multiplying the coefficients and you're adding the exponents. Okay. We did that back, we've done that a number of times throughout your learning algebra. Okay. But in a previous video that was done as well, okay, where 3x times 3x, okay, 3 times 3 is 9, x times x, 1 plus 1 on the exponents gives you 2. All right, same idea here. All right, 2 times, well, we're trying to figure out what we're multiplying by, though, this time, okay, to get this answer. 2 times 1 is equal to 2. X times x to the second. Why is it x to the second? It's because 1 plus 2 is 3. So we're trying to figure out that missing part so that when you do multiply by it, it's going to equal to this. Now, you don't need to write that 1 right there. I just wrote that just in case I needed it. But remember, when you have a variable there, you don't need the 1. You can keep it there if you want, though, like I've said before. Okay. And then what you do, so now you're done with this term. Now you look at this term. Now this time you do need to consider the minus if there's a minus there. 2 times what? 2 times what? And there has to be a plus or minus in between this to make it 2 terms, just like this is 2 terms. It's got to be the same number of terms here in the bracket as there is in the original problem. So we'll figure that out in a minute here, though. 2 times what is equal to negative 72? Okay, you can figure that out by dividing. Okay, whenever somebody says 2 times what is equal to negative 72, what they're saying, anytime you're trying to figure out the missing part that you're multiplying by, in other words, that is a division problem where you take the answer, negative 72, and you divide it by the thing that you're multiplying by that you know. Negative 72 divided by 2 is equal to negative 36, and that's why negative 36 is going to go in there. Okay. Now, do I need to multiply by an x? No, because if this is x to the first and this is the same exponent and same variable and same exponent, you don't want to put an x right there, you guys. If I had put an x right there, even if it was just x to the first, it wouldn't match up because x to the first times x to the first would be x to the second, and it doesn't match. So if this is the same exponent, x to the first, as this is x to the first, do not put an x right here. Okay, so that, you guys, is how you factor out the GCF. Find the GCF first, then you fill in the missing parts here so that it has the same number of terms, okay, as this does up here. And make sure there's a plus and minus in between there because it has to be 2 terms just like this is. But it's minus because it was negative 36 when we figured this out right here. Okay. So now, we'll get back to that problem here in a little bit. I just we're not done with it yet. Okay, so don't circle that. But wanted you to just get used to the GCF process there. Okay, now down here, this has a GCF as well. Now notice, starting out with your coefficients, the smallest one is 3. The factors of 3 are 1 and 3. Those are the only ones. Okay, sometimes you'll have more factors than that, but that's all that there is. 3, does 3 divide evenly into all 3 of these numbers right here? It does not. It doesn't divide into 17 or 10. So that means that the GCF must be 1. The GCF can never be less than 1. So if you get down to 1 and that's the only choice left, that must be the GCF at least as far as the coefficient part is concerned. We still got to look at the variable part. Okay, so theoretically, 1 is the GCF. I might erase that there, and sometimes we don't need the 1 as we talked about. But remember, like we did up here, when you have the GCF, you also got to look at the variables. Okay, now if you have the same variable that in every single term, then that variable is going to be in the GCF. But notice up here, though, for example, look at problem E. See how problem E has y to the second, y to the first, but then no y at all? If you have a problem where you don't have the same letter in all of the terms, that letter is not in the GCF. Only if it's in all of the terms can it be in the GCF. Just like the x was in both of these terms here, just like the y is in all of these terms here. Since the y is in all of the terms, that means that you're going to pick the one with the smallest exponent, just like we did up here. So we have y5, y4, and y3. The smallest one is y to the third. And since it does have a variable in it, I'm going to erase off the 1, although, again, you don't have to erase it off. You can keep it if you want. But I'll do that since we usually do that. We usually don't keep the 1 in that case. So that's the GCF right there, y to the third. Then you put a bracket next to it, just like it did right there. We'll fill it in a minute. Okay, but you put a bracket there. You make it big enough to have the same number of terms as you have up here. Because of the minus and plus, there's 3 terms up here. Therefore, there's going to be 3 terms in this bracket. How do we fill in those 3 terms? We multiply, or we pretend like we're multiplying. Okay. We say y to the third times what, you guys, is going to equal 10y to the fifth. Remember, that's 1y to the third. There's an invisible 1 there. So 1 times what is equal to 10? 10, right? And then just like always, okay, in fact, I'll write it down over here. You don't have to write this down, but 1y to the third times what is equal to 10y to the fifth. That's what we're asking ourselves here, okay? 1y to the third times what, that's a question mark right there, is equal to 10y to the fifth. So you go 1 times what is equal to 10, it's 10. And then you say y3 times what is equal to y to the fifth. Okay, if this exponent is smaller than this one, you need to have another y in here so that 3 plus that exponent is equal to 5. Well, as you know, if you have y to the third, y to the second will give you y to the fifth when you multiply terms, because 3 plus 2 is equal to 5. Okay, and so 10y to the second is the answer for that first part right there. Let's keep going here. Y to the third, again, you don't have to write this down, but 1y to the third, or y to the third, times what is equal to negative 17y to the fourth. Okay, so 1 times what is equal to negative 17? Negative 17, right? Okay. And then y to the third, since it's a smaller exponent than this one, we can multiply by something so that when we add the exponents, it's equal to y to the fourth. Okay, wouldn't that be equal to y to the first? Okay, because 3 plus 1 gives you the y4. And then finally, y to the third times what is equal to 3y to the third? Okay. So we got 1 times what is equal to 3, you guys. 1 times what is equal to 3? That would be 3. And since it's positive, you got to put a plus there. Remember, you either got to have a plus or minus in between these so that you'll still have 3 terms here, just like you did in the original problem. Same number of terms. Okay. And notice I closed it up. There's not going to be a y with the 3. The reason why is because, remember, when you have the same exponent here as you do here, you can't have a y right there, just like we said up here, where you had x to the first and x to the first. You can't have another x, otherwise it won't match up. If the exponent's the same out here as it is up here in the original problem, you can't put another x in the thing that you're multiplying by. It's the same thing here, okay, y to the third and y to the third. Okay, they're the same exponent, and so you can't multiply by something that has a y in it. It won't work. Now again, don't circle this answer. This is just the first step of the problem. Okay, But these are the problems that have GCF in it. But again, I just want to review with you the GCF process. Now, let's go over to problem A. We'll come back to B and G here as we go through the problems, okay, one at a time. Now, the first step to doing any factoring problem is to do the GCF. But, like I said, and I'll let you know whenever this is not the case, but almost always, whenever the GCF is equal to 1, and that means what, by the way? When the GCF is 1, that means that the GCF of the coefficients, 25 and 9, is equal to 1. Okay, and if you try to look at that, you'll see that it is. Okay, the factors of 9 are 1, 3, and 9. And 3 and 9 do not divide into 25. And so 1 must be the 1. Okay, but it's also true that you don't have the same letter in both terms, and so you can't put. Remember, we said a minute ago that if you don't have the same letter in all the terms, then you can't put that letter in the GCF, and so X and Y don't go in there as well. So here's the point. If your GCF is equal to 1 as far as the coefficient part is concerned, as we see here, and you're not able to put any letters into the GCF, then that means the GCF is 1. It is just 1. It is 1 without any letters in there as well, okay? So 1 with no letters, 1 with no variables, in other words, that means the GCF is 1, and we can typically skip this first step in that case, and we jump down into step 2. So we can skip the first step in problem A and jump down to step 2 then. Okay, now what do we do in step 2? What we do in step 2 is this. There's 3 different parts here. It all depends on what problem you have. Notice in this problem we have 2 terms because of the minus sign. It says if it has 2 terms, you try to use this formula. This does not mean that this is the only formula in the world of math that you can use for factoring 2 terms. But for now, this is the only one that you need to be aware of. Okay, so let's focus on this. Does this formula work for this? Let me show you that it does. Okay, here's how it works. The way you use this formula, if this formula doesn't work, then don't do it. Okay, but here's the way. If you want to try to use this formula, what you do is this. You put 2 brackets, and the brackets are only big enough to fit 1 term in them. 1 term. Then you put an exponent 2 attached to both of those. That's these 2 exponents right here. The A and the B, I want you to pretend like the A and the B are like these little brackets right here. So we're going to put a minus in between that, just like the minus that's in between here. And then what I want you to do is I want you to try to fill in these 2 things right here. So I wanted to show you a problem from a different video here to remind you, when you have a single term, which we're going to in the current problem, like this one, with the 2 on the outside, remember you take this number to the 2nd power, but then you multiply the exponents. Coefficient to the power, multiply the exponents like it's done right here. Okay, and so we're going to be like doing that backwards here. Okay, we're going to be asking what number is taken to the 2nd power, what coefficient is taken to the 2nd power to equal 25. Isn't that 5, you guys? Okay, yes, it's also -5, but you don't have to do the negatives. You can just do the positive possibilities here. Then, isn't it true that 2 times 2 is 4? And so x squared would work here, wouldn't it? X squared, we multiply the exponents, that matches up with it. It just has to match up. Okay, so like if that had been x to the 3, you wouldn't be able to do this because then there wouldn't be a number that you could multiply by 2 to equal 3. But because it's 4, you can do it. Let's try that again, and don't include the minus sign. The minus sign was brought down here in between the brackets, so that doesn't count here. Just look at the 9. 9, what number is being squared to equal 9? That would be 3, right? And then isn't it true that 3 times 2 is 6? So I can bring down, don't forget to bring down the letter as well. Okay, you got to have a letter in order to multiply the exponents. 3 times 2 is 6, and so it works. Okay, now, since I was able to fill in those 2 brackets with the exponents attached to them, this formula says the following. It says that whatever that first bracket is, goes here. That's why it says A and A. It says that whatever's here goes here. It also goes there. Now, you don't need to write down that little bracket again when you do this. We do need to write down these bigger brackets, but just like you see the bigger brackets here. But the 5x squared goes here, and it goes here. Okay? And so there you go. And so then the b, that means that whatever's in the second bracket, because that's what the b represents, that goes here and here. And so 3/1 to the third goes here and here. But don't forget, it also has a minus and a plus in the middle of each bracket. So we got to put a minus and a plus, and there you go. Okay? All right. Okay. So usually, there is a step 3 right here. We'll get into that towards the end of the video. But usually when you break it, usually when you do step 2 and you're successful, you won't always be successful when you try to do step 2. We'll get into that as well. But if you are successful in producing 2 brackets from step 2, I'm not talking about these 2 little brackets. I'm talking about 2 brackets that each have more than one term in it. Okay? If you're successful in doing that, then you're usually going to be done. Step 3 is something that we rarely do. Okay? I'll explain when we do that coming up. Okay, now as we go on into step 2, I want to remind you that if step 1 did work, if you actually did factor out a GCF there, you still got to do step 2. Okay, so it's a little bit more involved, problem number 2. You got to do step 1 and step 2 this time. But the good news is that step 2 is very similar to what it was before. See how the bracket has 2 terms in it because of the minus in between the x squared and 36? And so what you do is you treat the bracket the same way we treated this problem up here. Okay, it's as if this is its own separate problem now, x squared minus 36. In fact, I want you to pretend like this is its own separate problem. Okay, pretend like the problem is starting over with this. Don't forget about the 2x, so that's still there. Okay, in fact, we're going to bring that down into the answer right here, and we'll have some stuff next to it. But what we need to do is we now need to take this, pretend like it's its own separate problem. Okay, you don't have to rewrite it up here, but I'm just kind of taking that approach where I'm pretending like we're starting over here. And what you do is, since it has 2 terms, okay, and when I say start over, I don't mean you have to do the GCF again. Okay, what I mean is that start over with step 2. Since it has 2 terms, try to do this thing again, which means what? It means to try to do these 2 brackets again, these 2 little brackets, and try to fill them in. What would be taken to the second power to equal to x squared? Remember, that's 1x squared. So that would be 1x, wouldn't it? Okay, 1, the invisible 1 right there would give you the 1 here. When you square 1, you get 1. Okay. But then 1 times 2, the invisible 1 on the exponent part, 1 times 2 is 2, and so it works. Okay. Remember, the minus sign is separate like it was in the last problem, so just look at the 36. What's being squared to equal 36? The 6, right? Okay. So what does that give me here? Okay. It means that x squared minus 36 breaks down to what? Well, according to this formula again, the x is, see, this right here is the x, and this right here is the 6, as we saw here. X for the A, 6 for the B, and so we get x and x in these 2 spots, and we get 6 and 6 in these 2 spots. What do we get? X minus 6 and x plus 6. Don't forget to bring down the plus and minus in the middle of each bracket. Okay, and do not, as I said already, do not forget to bring down that GCF as well. Okay, and since we produce our 2 brackets, okay, we are done. Again, there will be a rare exception to that at the end of the video where sometimes we get 3 brackets, but usually it'll be 2, if that. Okay, now all the rest of the problems except for G have a GCF of 1, and we're going to skip that first step. So I'm going to jump right into step 2 here in problem C. Notice it has 4 terms, minus, plus, and minus. That breaks it up into these 4 terms right here. Okay, it says if you have 4 terms, try factor by grouping. Okay, you have to pick the right amount of terms here. Each different number of terms has a different method. 3 terms, you got this thing called the Berry method that we'll get into in a few minutes. Okay, but for 4 terms, it's factor by grouping. What does that mean? Factor by grouping means that we do this. We group the first two terms and we group the last two terms, and then we factor the GCF out of each group. Okay, not out of the whole thing. All right, we already tried to factor the GCF out of the whole thing, and it was equal to 1. Or at least I tried it earlier, and I know that it's equal to 1. You could try it as well if you want. But the point is that if you factor the GCF out of each group, the GCF won't always be equal to 1. It usually won't be. Let's try it. If I factor the GCF out of this group, start out with the 20 and the 10. The biggest number that divides evenly into 20 and 10 is 10, and you can test that out by looking at the factors of 10, which is 1, 2, 5, and 10. Remember, you look at the smallest number, 10, out of 20 and 10. You start out with the biggest number. Oh, but that works, though, so you don't have to go down to 5 and try that, and then 2. No, 10 works, and so that will be the GCF for the coefficient part. Then you got to look at the x3 and x2. Remember, we're just looking at these two terms. In these two terms, the bracket, or pardon me, not the bracket, the variable is the same in both of them. And so that means we need to put that variable x into the answer. What's the smallest exponent? Again, just in this grouping. Just in this grouping, it's 2. Okay, so what you do now, you guys, is you factor the GCF out of that grouping right there, not out of this one. Okay, we'll do that in a minute. Just out of this grouping. So 10 times what is equal to 20? It's equal to 2. X squared times what is equal to x to the third? Just like we were doing with the x squared and 36, and then also problem G. What are you multiplying by? Well, since 2 plus 1 is equal to 3, you got to put x to the first right there. Okay. And then we go to the next part. 10 times what is equal to negative 10? 10 times negative 1 is equal to negative 10. Now this time I am going to write the 1, and I'm going to keep it this time. And you know why I'm going to keep it? Is because x squared and x squared are the same, so I'm not allowed to put an x right here. Remember we said that if you have a term that has 1 or negative 1, but it has no variable, you got to keep that 1 there. You can't just leave it invisible. You can't just write the minus there. Okay, if it has no variable, you've got to write the 1 or the negative 1. And so that's why I wrote the 1 and I kept it. Okay, now here's the thing. You now group this part, okay, and if the two brackets end up being the same, you'll be able to produce two brackets like we have in the last couple problems here. But the brackets have to be the same. Will they be the same? Okay. What is the GCF of this? Again, we look at the 6 and the 3. Okay, as we saw earlier, the factors of 1 and 3 are, pardon me, I said that backwards. The factors of 3 are 1 and 3. Okay, so we start out with the 3. If that doesn't work, then we look at the 1. Okay, but start out with the biggest one. Does 3 divide into both 3 and 6? Yes, it does. It divides evenly into both of those. Okay, and in other words, 6 divided by 3 is equal to 2, and 3 divided by 3 is 1. They both divide evenly. So I put down this 3 right here. Now here's the thing, you guys. You got to have a plus or minus in between the bracket and the second GCF that I just found here. There's the first GCF over there. Okay, you got to have a plus or minus here. Okay, you might be wondering, which one do you do? Okay, well, usually it's going to be plus. Sometimes it'll be minus. It's whatever works. It's whatever makes this bracket the same, if that's even possible. Okay, so do you want to do 3 or negative 3? Okay, again, you want the second bracket to equal 2x minus 1. So does positive 3 equal, does that give you 2x minus 1 when you factor it out of this grouping here? It does, because 3 times 2x is indeed equal to 6x. And 3 times negative 1, because we want it to be the same as this, that does equal minus 3. Now, don't just write down 2x minus 1 because you're hoping that it's going to be the same as this. It actually has to be, so make sure to check. But since it is equal to that, when you do positive 3, you got to put a plus right there. If positive 3 did not give you the same bracket as this one, then try negative 3. And if negative 3 doesn't work, then that's different. Then you might have to rearrange the terms. We're usually not going to have to go that far. Yeah, sometimes you got to rearrange the terms in a very rare case. And then sometimes it just ends up happening that you can't produce two brackets, okay? Again, we'll talk about when you can't produce two brackets down here towards the bottom of the video, the bottom of the worksheet. But we were able to do it. We were able to make these two brackets the same. When you're able to make the two brackets the same, when you're doing factor by grouping, I'm not talking about one of the other methods. I'm just talking about factor by grouping. You want to make the two brackets the same. When they are the same, here's what you do. You only write it once down here. You don't write it twice again. You write it down once. And then you take the two things that was multiplied by the 10x squared and the plus 3. You got to include the plus there. If it had been minus, you'd put down minus 3. But you bring all that down in a separate bracket like that. And that is your two brackets that you get when you factor this thing. Okay? So that is factor by grouping. But again, please make a note. Those brackets need to be the same. Okay? And if they're not the same, they're not the same. Don't try to make them the same when they're not supposed to be. Okay? Now, in this next problem, once again, the GCF is 1. Like I said, I've already checked it. Except for problems B and G, it's going to be 1. So then, since it's got 4 terms, we're once again going to do factor by grouping. Okay? And so we do that. If I do the GCF on this first part here, the smallest number between 6 and 24 is 6. So you look at the factors of 6. Does 6 work? If 6 doesn't work, then you try 3. And if 3 doesn't work, then you try 2, and so on. 6 does work because it does divide in evenly into both 6 and 24. But we still got to do the variable parts. Since x is in both terms, we got to put it in the answer. But what exponent do I use for x? Since I have x to the second and x to the first, I'm going to have x to the first. Okay, you can just say x, same thing. Now y is in both terms, and so that means I got to put that in the answer as well. But what exponent do I use for that? Y to the third and y to the second. Smallest exponent is y to the second. So that's the GCF of the first grouping, you guys. Okay, and so now what you multiply by in order to get the bracket that goes with the GCF. 6 times what is equal to 6? It's going to be equal to 1. 6 times 1 is 6. I'm not going to write the 1 there because I already know that there's going to be some variables that go with this. X to the first times x to the first is x to the second, right? 1 plus 1 is 2. Y to the second times y to the first, 2 plus 1 is 3, is going to give me y to the third. And so that's the first term. Next term, negative 24. 6 times what is negative 24? Negative 4. Notice, however, that x to the first and x to the first are the same, so you can't put an x in there. Y to the second and y to the second are the same, so you can't put a y in there. So it's just going to be negative 4 only. Okay? Again, if those exponents are the same, you can't put that same letter in there. Now we go to the next part, and 7 and 28, the factors of 7 are 1 and 7. Does 7 work, though? Otherwise, it's going to be 1. Okay? 7 does work. Okay? And by the way, you don't see that in these problems, but this is the one exception to where you do need to factor out a 1, even if 1 is the GCF, because you have to be able to produce another bracket here in order to see if it's the same as this bracket. So if this GCF had been equal to 1, which it's not, but if it had been, you'd still have to factor it out in order to get a bracket. You need to factor out a GCF in order to produce a bracket. I'm just letting you know that, but in this case, the GCF is going to be 7. Now, here's the problem, though. If you factor out positive 7, the bracket's not going to be the same, because then this would have to be don't write this down. I'll erase it in a second here because it's not right. It would have to be this right here. Okay, if you factored out, oh, I'm sorry. It'd have to be plus 4. So if I had factored out positive 7, then when you figured out what to multiply by, it'd have to be negative and positive in order to get negative and positive here. Okay, in order for the brackets to be the same, not only do the terms have to be the same, but that includes the signs. Positive, negative, this also has to be positive, negative. Okay, so since that's negative, positive, that's not going to work. So when that happens, if the positive part of the second GCF does not work, what you do is you make it negative and see if that works. Okay, and oftentimes it will. Okay, because usually we're not going to have to do that thing I was talking about a few minutes ago about rearranging the terms if the negative doesn't work either. Usually this will work. So, and you'll see there, negative times xy, that's going to be equal to negative 7xy. Negative 7 times negative 4 does equal positive 28. So the two brackets are the same. And they need to be the same. But what did we learn in the last problem? We learned that when they are the same, you guys, when they are the same, you bring it down once, you bring down that bracket just one time, and then you take the two things that were being multiplied by it, including the minus, just like in the last problem I included the plus there, and bring down the minus as well. 6y squared minus 7 is your other bracket, and that's your two brackets right there. Okay, so that, you guys, is how we factor when you have four terms. Okay, so we've learned about how to factor with two terms. We'll still have a little bit more to talk about with that coming up. We learned how to factor with four terms. Now, how about three? Okay, again, problems E and F, already we know that the GCF is 1, so we jump right over to step 2. We can skip step 2, okay, and try to do what they say about three terms. Okay, if it's in this, this is the one you're usually going to see, where you have a variable squared. It doesn't have to be the letter x. It could be y. See how you have y to the second, y to the first, and then no y at all? Here it says x to the second, x to the first, no x at all. Okay, it doesn't matter what the letter is. The point is that if it's the letter being squared here, whether it's x, y, or some other letter, the a is actually supposed to be the coefficient. That's not really a letter there. You just put a letter there. We just put a letter there to represent that coefficient. But the if the x is being taken to the second power, or whatever the variable is, and then that same variable is taken to the first power in the second term, and then there's no variable at all, that's what we're talking about here. That's when you can do this thing called the Berry method. I'll get into these other two possibilities here in just a moment. Okay. By the way, the pluses can also be minuses here. Okay, if you've got minuses there, like minus 14, that's fine. But if you have variable squared, the same variable in the middle, and then no variable at all at the end, that's what we're talking about. Okay, that's when you can do the Berry method. What is the Berry method? This is assuming you've already tried to do the GCF, which we already did. I'm just reminding you. What you do is this. You go 5 times, this is the Berry method, 5 times negative 14. You take the first coefficient times the last one. That's assuming that it's in this order, with the variable squared here and the no variable at all over here. 5 times negative 14 is negative 70. And here's what you do. You list out the pairs of factors for negative 70. What do I mean by pairs of factors? Okay, what you do is this. You always start out with 1. And what do you get when you have negative 70 divided by 1? That's equal to negative 70. So that means that 1 times negative 70 is negative 70. Okay, now when you have a negative number that you're trying to find the factors of, if you have a pair, and it's always going to be 1 positive, 1 negative. Okay, because otherwise it's not going to equal a negative answer when you multiply them. These two numbers got to equal this when you multiply them. But if you've got a positive and a negative, you also have a negative and a positive. That's also a possibility. Okay, so take that into mind as well. Okay, so when you this is just when you have a negative number right here, when you multiply these two numbers, you're always going to have two pairs for each different pair of factors that you have. So for 70, 1 and 70 would be one pair of factors that multiplies together equals 70. You'll always have two pairs for that. Positive and negative, negative and positive. Okay, now here's the thing. We got to keep on going and keep on listing out these factors until we find a pair that adds up to the middle number, positive 33. You got to include that positive right there. If that had been negative 33, then you'd have to say negative 33. Okay, these two numbers add up to negative 69. Your calculator can do that for you. These two numbers add up to positive 69. That's not even close to 33. So we keep going. What's the next pair? How do we figure that out? The way we figure that out is by we then take the next number after 1. After 1, we got 2, right? 2, negative 70 divided by 2 is what, you guys? Again, your calculator can figure that out for you. Negative 70 divided by 2 is negative 35. Okay? But remember, if you have positive negative, when this number up here is negative, you also have negative positive. Do either one of these pairs add up to 33? Yes, this one does, doesn't it? Doesn't that one add up to 33 if I add up those two numbers? Okay. Now listen very carefully here. Okay. This is what makes there's a lot of different ways to do these problems here when you got the three terms. The Berry method is a little different. Okay. But I think it's I've tried out a lot of different methods over the years teaching this. This is the one that I found is the most popular. Okay. What you do is if this is 5y squared, you say 5y, 5y. Okay. If that had been 6y squared, you just say 6y, 6y. Okay, for example, for this one, it's going to be 4x and 4x. That doesn't mean the problem's going to end up looking like that. This is just the following step. We still got more steps to do. What you do at this point, though, is you take the negative 2 and you put it next to that in the first bracket. Since 35 is positive, you have to say plus 35. Do not just say 35 only. So for these numbers, if one of them is positive, you got to put a plus in front of it. Still one more step we got to do. This is the toughest step if you don't practice this, okay? We got to factor the GCF out of each one of these brackets. I know we already considered the GCF and everything, but with the Berry method, there is one step within the Berry method, okay, up here, where you have to do the GCF of just the two smaller individual brackets here, okay? What is the GCF of 5y and 2? What's the GCF of 5 and 2? Well, it's going to be 1. And we can't put y in the GCF because it's not in both terms. So the GCF of this bracket is 1. GCF is equal to 1 for that one right there. Just talking about this bracket here. Okay. What's the GCF of this bracket? The GCF of this bracket is equal to 5. And the reason why it is because 5 divides evenly into both 5 and 35. And y, again, it's not in both terms, so you can't put that in there with the 5. So here's the thing. You have to factor the GCF out of each bracket. Okay? But then you have to get rid of it. Unlike up here, where if you factor GCF out of the original problem, you got to keep it. You factor GCF out of the original problem, you got to keep it. But if you factor GCF out of one of these brackets in the second step of the Berry method, then you got to discard it, get rid of it. Now, as we've said earlier, when you factor out a 1, it doesn't change anything. So the 5y minus 2 is going to stay the same, and we're going to discard that GCF. We then factor the 5 out of this. Wouldn't that be equal to y plus 7 if I had factored that out? Okay, wouldn't it be 5y? You don't have to write this down up here. But if I factor out the 5, it would be equal to 5y plus 7 to get 5y plus 35. So that's what I mean there. You factor out the 5, you discard the 5, but you keep the bracket. And that is the Berry method, and we got our two brackets. Don't worry, we'll do more practice here if you need that. Okay? We'll do more practice. Okay? So, you discard the GCF after you factor it out of each bracket. Let's keep going here. How about problem F? Okay. 4 times 18. That's equal to 72. Okay. Notice that's positive. It's not negative. So you don't have that situation where it's going to be two different pairs of factors. You're not going to have positive, negative, negative, positive. Okay. and we start listing out the factors. You always start out with a 1. 1 and 72. You might be thinking, hey, what about -1 and -72? Okay, well, that's a possibility normally as well, but here's the thing. A negative and a negative will never add up to a positive. Remember, with addition, negative plus negative is always negative. We're not talking about multiplication here, okay? We're talking about addition. In multiplication, negative and negative equals positive, but not in addition. Okay, and these two things have to add up to 27. Now, if that had been -27, then you'd want to do negatives because, again, negative and negative adds up to a negative. We'll see that example down here in problem G. Okay, so if the middle is positive, you want these to be positive. Okay, if the middle is negative, then you're going to want them to be negative. We'll get to that in a minute. But if the number on top is negative, then you just have to do all the different possibilities. Positive, negative, negative, positive. So if it's negative, you got the two pairs of factors like we see here. If it's positive, then it all depends on what the middle is. If it's positive, then these are both positive. And you only have to do one pair. You don't have to do the two pairs for each different pair of factors like we did here. Okay. So 1 and 72, that adds up to 73. That's nowhere close to 27. The next number after 1 is 2. 2 does divide evenly into 72. If it didn't, we would just skip that number and go on into the next number, which is 3. So 72 divided by 2 is 36. 2 plus 36 does not add up to 27, so we keep going. Let's try 3. 72 divided by 3 on your calculator is 24. 3 plus 24... Hey, we got it. That is equal to 27, isn't it? Okay. 3 plus 24 is equal to 27. That's why we picked that one. So what do? As I mentioned in the last problem, because this is 4x squared, you have to do 4x and 4x. Do not just say x and x. That will not work. Okay. 4x and 4x. Then we take this, and since they're both positive, we're going to say plus and plus here, plus 3 and plus 24. Okay, so that's the first part of the Berry method. The second part is find the GCF of each bracket and then discard it after you factor it out. The GCF of this is going to be equal to 1. I just figured that out the same way we've been figuring out in the other problems. The GCF of these two is 4. And so what you do is, since the GCF is 1 right here, if you factor it out, it's going to stay the same as it always will when you factor out positive 1. And you discard that GCF. Here you factor out the 4, and that's going to be equal to this, isn't it? Again, you don't have to write this down off to the side. I'm just making sure you can see what I'm doing. So this becomes this here. You then discard the 4, and you're just left with the x plus 6. And we got our two brackets. Okay. Okay. So in problem G, we do exactly the same thing, except for just like in problem B, if you have a GCF in the original problem that you factored out, that one you've got to keep. Okay, you can't discard that one. The GCF from the original problem, you've got to keep that. Okay. Then, since this is the variable to the second power, variable to the first power, and then no variable at all, we do the Berry method again. That's when you do the Berry method. Okay, so let me look at that down here. 10 times 3. 10 times 3 is 30. So we list out the factors of 30. Until we find a pair that adds up to what? -17. Now remember, if this is positive, then these pairs either have to be positive, positive, or negative, negative. Because they're supposed to multiply together to equal this one. They're supposed to add up to this one. Multiply together to be this one, add up to this one. So, because they have to add up to a negative, it's not going to do me any good to do negative. It's not going to do me any good to do positive 1 and positive 30. Positive and positive never adds up to a -17 or any negative number for that matter. And so I'm just going to try negatives here. -1, -30. That does not add up to -17. However, the next number is 2. 2 goes into 30 15 times if you divide that. but we're only going to do negatives here because there's no way that it would add up to a negative 17 otherwise. And sure enough, don't those two numbers add up to negative 17? Negative 2 plus negative 15? Same thing as negative 2 minus 15. Okay, so what do? Since this is 10y squared, you guys, you got to do 10y and 10y. Not y and y, but 10y and 10y. Take the minus 2 and the minus 15 right there, and you put them in there. Okay, since they're both negative, they're both going to have minus. Then the last step of the Berry method, you can ignore the y to the third for the moment. We're going to keep it in the answer, but that has nothing to do with the Berry method. That's just separate. So I'm just going to look at the two brackets right here. The GCF of the first bracket is 2. The GCF of the second bracket is 5. So again, I factor out the 2, bring down the y to the third, keep that in there. Factor out the 2, that's going to be 5y minus 1. And remember to discard that. Then factor out 5 out of this bracket. That's going to give me 2y minus 3. Okay. And then that is going to be your two brackets right there with the GCF included. Okay. So most problems are either just going to have two brackets or they'll have two brackets with the GCF in front if there was a GCF in the original problem. That's what all these problems are, right? Okay, all these problems are like that. Okay, again, the one exception to that will be on the next page here, just a couple of problems here. Like I said, it's a rare situation when that happens. Again, the GCF here is 1. It's in that Berry method type of situation where you got the variable squared and then the variable to the first power and then no variable at all. There's an invisible 1 in the front there, so we have 1 times 8 is 8. 1 times 8 gives me 8. And then I list out all the pairs of factors for 8. Since that's positive 3, I'm only going to do the positive possibilities. Okay, so when you get a positive number right here, the two numbers have to be the same sign. We've seen that in the last couple of problems, but the middle sign tells you which sign that is. Because negative 1 and negative 8 is never going to add up to a positive 3. Okay, so we try 1 and 8. That's not going to equal 3 when we add those up. The next number is 2. 2 times 4 does equal 8, but does 2 plus 4 equal 3, you guys? No, it does not. So then we have to keep on going. Let's see if something else works. How about 3? 3 does not work, okay, because 3 doesn't go into 8. The next number is 4. Now, here's the thing. If you do this, if you list out these factors the way I'm doing it here, where you start out with 1 and then you go to 2 and you always go up by 1 each time, if you guys eventually run into a number that's on this side, okay, where you put the smaller numbers on the left, the bigger numbers on the right. If you run into a number that's already on this side, then that means that you're just going to be repeating yourself after that. You can stop listing out the factors. Because if I did the 4 right here, I would just get 4 and 2, and it's the same two numbers I already got. Okay? And so you don't need to do that. All right? Now, here's the thing, though. That means that these are the only factors of 8. But neither pair works. Okay? So that means that you cannot break this down to two brackets. Okay? If you do the Berry method and no pair of factors adds up to the middle, then that means that you can't break it down to two brackets. So what do? Do we say no solution or something like that? Not quite. It's similar to that, though. Here's the thing. If the GCF is equal to 1 and you can't break it down to two brackets, we call that prime. It's kind of like a prime number when you're listing out factors. Okay? So this happens when? This is just something to write down so you'll know later on why I wrote this down. Okay? It's prime when what? If the GCF is 1 and you can't what? You can't break it down into two factors, two brackets, two factors, same thing. Okay, two brackets. There we go. And so that's what prime is. In this next problem here, This is exactly the same method, the Berry method, even though it looks differently. When you have the variable to the fourth power, the variable to the second power, and then no variable at all, it's the same thing as having exponent 2, exponent 1, and no variable at all. Okay, you'll see that listed up here. x4, x2, and then no variable. Same thing if it had been, this is not on this worksheet, but in case you see it in the future, if you have x6, x3, and then no variable at all, that also would be good for the Berry method in a 3-term polynomial. Okay. And so we do the Berry method. Again, the GCF is 1. I've already checked that. 1 times 20 is 20, right? Since this is positive, the middle sign tells us what the numbers are going to be. Since it's negative 9, this is going to be negative 1 and negative 20. That's the first pair of possibilities. That does not add up to negative 9. After 1, of course, you get 2. 2 pairs up with 10, but we need them both to be negative, so we do negative 2, negative 10. Those two numbers do not add up to negative 9, so let's keep going. Negative 3 does not divide into does not divide into 20, and so we go to 4. 4 and 5 work, okay, because 4 divided into 20 is 5. They both got to be negative. Does that add up to negative 9? Yes, it does. Okay, but here's what's different about this problem, though. This is the one big difference, even though we're doing the Berry method. Okay, this is 1x to the fourth, right? Okay, so you don't say 1x and 1x like you normally would. Since this is 1, you do say 1 and 1. That is true. That is true. Okay, but you don't just say x. If it's x to the fourth, you got to say 1x squared, 1x squared. Okay, if it had been x to the sixth, you'd say 1x to the third, 1x to the third. Okay, that exponent's always half of what this is. Okay, so like for example, if this had been 2x to the fourth, you guys, then you do 2x squared, 2x squared. So you're still doing that same thing with the coefficients that you were doing before where it stays the same on that first step of the Berry method. But as far as the exponents, they're always half of what they originally were. Here you got x to the first, x to the first. 1 is half of 2. And so again, it's the same thing here. The exponents are half of what they originally were. Okay, and since the coefficient is 1, it's still 1 here in both of these terms. Then you do the same thing, okay, that we did in the Berry method before, where you just put those two numbers in. Okay, and then you have to do the GCF thing, but the GCF is going to be equal to 1 in both of these. And so, as you know, it's you don't even need to write this down again, but just to be consistent with the process of doing the Berry method and considering the GCFs and everything, I'm just going to write it down again. It didn't change because factoring out 1 does not change anything. But again, you don't need to write it down again if you don't want to. Now, here's the thing, you guys, and this is going to happen on the last two problems on the next sheet as well. Okay, let's go up and don't circle that yet. Okay, don't circle. In fact, don't circle it. Okay, sometimes, look at step 3 right here. It says in step 2, if you were unable to break the problem down into 2 brackets, then the factoring process is done. Okay, we saw that in problem H. Okay, we stopped. All right, but if step 2 produced 2 brackets like it has in all the other problems, then occasionally, it doesn't happen that often, but occasionally, one of those 2 brackets can be broken down or factored into 2 more brackets, which would then give you a total of 3 brackets, by the way. I'll show you that in a second. And it's usually with this formula. Not always, but very, very almost all the time, let's put it that way. It will be through this formula. See how x squared minus 4 fits into that formula? Because I'll write it down here. X squared minus 4 is x and 2 inside those little brackets, isn't it? So the point is that if you get 2 brackets and one of them fits into this a squared minus b squared formula, you need to break that down further. Okay? it's not completely done factoring yet until you've done that. Okay, you'll notice on all the other problems that we did, though, and all the other problems we did, none of these other brackets fit perfectly into the a squared minus b squared formula where every part of them fit. In other words, every part of them was something being squared. Okay. For example, look at this bracket right here. Do you know what's being squared to equal 10? No. Okay, we know if this was 9, that would be different, but not for 10. Same thing with 3, right? What's being squared to equal 3? See how that doesn't fit? Okay, and then also, if you have a variable to the first power, okay, you can't square something to get x to the first power. Okay, that's why these ones, well, that's one of the reasons why these brackets couldn't be broken down any further. Okay. Yes, the x squared could be, that's x to the first being squared, but 5, what's being squared to equal that? We don't know. Okay. So none of these other brackets fit into that because you can't figure out what's being squared. Here, 1 is 1 squared. Again, you don't have to write the 1. I'm just emphasizing that. X squared means x to the first squared. 4 means 2 squared. So every part of this is something being squared. Everything fits. Okay, every part of the bracket has to fit into that formula. In other words, every part has to be something being squared in order to fit into that formula. This is the one case where that does happen. Every part does fit. So what is this? This is going to be x minus 2 and x plus 2. Okay. So here's what we do. We take the x squared minus 4 and we replace it with these two brand new brackets that it broke down to. So it's like taking this one bracket and breaking it down to two smaller ones. And then this third bracket, you might be thinking, hey, that looks like it'll fit too. Almost, but 5 doesn't work, does it? Okay, we don't know what's being squared to equal 5, so that doesn't work, does it? So that one, we leave it alone. Okay. And so like I said, sometimes when you get your two brackets, you guys, sometimes one of those two brackets will fit into this formula and needs to be broken down further. And what will happen is that you'll end up with 3 brackets. Let's do that. Let's get some more practice on that. The next 2 problems on the next sheet here are exactly that same type of situation. You'll see here, and again, both of these problems have a GCF of 1, so we'll skip that step. In this first one here, x to the 4th and y to the 4th both fit. We know it's being squared to equal both of those because we know that 2 times 2 is 4. 2 times 2 is 4 over here as well. And we know that the coefficient is 1, so 1 squared is 1, so that fits as well. And so we were able to find what goes into each one of those brackets. So, and why am I even doing this? Okay, why am I doing this formula? It's because it's 2 terms. Remember, we try to do the a squared minus b squared formula whenever we have 2 terms, right? Okay. And so, according to that formula, that means that whatever's in the first bracket goes in the beginning of the first bracket on the next step and the beginning of the second bracket as well. The y squared goes into the back side of each one of those brackets. It's just like here. Okay. X goes into the front of each bracket. 6 goes into the back side of each bracket. Okay, whatever's the first little bracket, first part of each big bracket. Second little bracket goes into the second part of each big bracket. Second part of each big bracket. Okay, and so we've got this right here. But check it out, you guys. We've got our 2 brackets. Normally we would be done because we've got our 2 brackets. Okay, but just like we saw in the last problem, one of these 2 brackets, this one right here, okay, can break down, okay, because this is equal to x to the first squared and y to the first squared. Now you might be wondering, hey, doesn't this break down too? Okay, I know it looks like it does, but it actually doesn't. Okay, let me explain why. It's because of the plus. Notice in that formula that we've been talking about for this thing down here, it's always minus in the middle. Okay, when you have a squared plus b squared, okay, when you have something squared plus something squared, there's no formula for that. You can't break that down into two brackets. You cannot do it. Okay, so please make a note of that, okay? But this one can be broken down. So this becomes what? I'm just going to write it down here as well here. You don't have to write it down twice. But this breaks down to x minus y, as I wrote down at the bottom of the screen here, and x plus y. But as we said, because this is plus, that one does not break down, and so therefore it's going to be staying the same, like that. This one's quite similar, actually. Okay, again, the GCF is 1. Okay, it's got two terms, so we're going to try to do the a squared minus b squared formula again. Let's see if it works. 1y to the 4th, wouldn't that be 1y squared? 2 times 2 is 4. And isn't this 9 squared equal to 81? So according to the formula, the y squared goes in the first part of each bracket. The 9 goes into the second part of each bracket. You put your minus and plus in there according to the a squared minus b squared formula. Okay, minus and plus. But because that first one, again, I'll just write it down here. Okay, you don't have to write down this additional thing like I've said before. All right, I went too fast right there. Hold on. There we go. So this is going to be y squared minus 3 squared, isn't it? And so that leads to what? That leads to y minus 3, y plus 3. Now I do need you to write down the final answer. I was just saying you don't have to write it down again down here as well, but you do need to write it up here. Take the y squared minus 9 and replace it with y minus 3 and y plus 3, because that's what y squared minus 9 is equal to, as we found out down here. So y squared minus 9 is equal to these two smaller brackets. All right, that's what factoring is all about. Breaking something down into two smaller parts. Sometimes it's more than two, as we can see here in these last few problems where we have 3 things being multiplied together. Okay. And again, why did I not factor this y squared plus 9 on the end? It's because of that plus right there. Okay, as we mentioned in the previous problem. Okay. So to review here, you guys, most problems have 2 brackets. Most problems have 2 brackets. Occasionally you'll have a GCF that needs to be factored at the beginning before you produce the 2 brackets. And then in an even more rare case, I know we saw 3 problems here do it, but it won't usually be that much. I just wanted to give you some practice. But in an even more of a rare case, you will have a situation where you get your 2 brackets, you guys, but one of those 2 brackets can break down further by doing the a squared minus b squared formula. Okay, and so that is basically what factoring polynomials is all about. So that concludes our factoring polynomials video.